Hello and welcome to this new episode about building the B.B.M.1930s model railroad layout. I'm going to show you my tried and true method to lay track and to install a turnout. So this is the location. It's the southern area of the Basel-Badische Bahnhof. So far the two mainline tracks were just connected by a reverse loop. You can see right here. But for the next step on the main line I need a crossover at the end of that station. In this episode I will lay that little piece of track in blue and the red turnout. And this is the complete future track plan with the lower track leading to the new engine facility. The temporary track was just held by a few nails, so I was very quick in tearing down the tracks and preparing the area for the new turnout. After cleaning up a little bit, let's unbox the turnouts. I am using the fantastic turnouts made by Weinert called Mein Gleis. I think it's unique in quality, realism and function. And they match perfectly because they are actual models of the turnouts in use at the Deutsche Reichsbahn in the 1930s. Before going ahead with the turnouts, I need to add that little piece of track between the new and the old turnout. I have a leftover piece of track and I'm going to cut it to the right length of 39 millimeters. I'm using marking gauge and a permanent marker to mark the 39 mils. To better understand the next step, let's take a look at the rail joint system that Rolf Weinert invented. The rail joiners are detailed and fit perfectly into the special ties for the joints. For the little piece of track I need to know how much free rail I have to leave beyond the ties. Calculate the distance between the end of the rail and the tie. I need half of this distance plus one tire spacing. So 5.25 plus 4.5, that is 9.75. And by pure chance I built a small gauge to exactly mark that distance at the end of the track. Considering the marks, we have to cut between the third and the fourth tie. I'm using the Xuron track cutter to do this. Before cutting the rails with the same tool, I need to pull apart the ties so I have enough space to access the rail. I try to do a 90-degree cut. I think that's good enough. The second cut is not good enough, so I have to file it a little bit to make it more like 90 degrees. Now I check if the length is correct. It looks good. Now we need the rail joiners. They are sold in a set of 16 on a molding tree. Now I need to cut some out from that tree. That's a macro of the rail joiner. In general these joiners are too tight, so I need to widen them up. And I just built a small tool with a piece of rail that has been filed at the end, and this way I can pull it inside and this way open a little bit the joiner. Now I try to slide them into the rail. It's easier to do that offline, of course. If anything is not working, like this one. It's a little bit hard to get in. Alright, now it's in. Because of the fine details, the joiners have pretty sharp edges that hurt the fingers. I will solder feeder wires underneath the rails, so I need a little bit more space in between the ties, so I'm going to cut those little noses so I get more space to place the solder. Now we are back on the layout. I need to figure out where the ties exactly are for the feeders, so I have to position the little piece. The white piece of styrene you see is a gauge to keep the distance of 9.75 mils between the ties. With a ruler I make sure that everything is aligned. The ties are in the correct position, and now I'm putting marks on the rails where the solder will be for the feeders on both sides. And with a white pencil I'm putting marks where the holes need to be. Now I'm cleaning the bottom surface of the rail with a fiberglass eraser brush. The marks on the sides of the rails have to be transferred to the bottom so I can see them when soldering. Now I put a tiny drop of solder. Now preparing the feeder wire. To prevent damage, it's important to not keep the soldering iron too long on the rail, just a few seconds. Because the turnouts have already their joint tie at the end, we only need one of them on each side, so I'm going to cut them apart. We are now ready for installation. I'm placing the special joint tie and then inserting the feeder wire into the holes. Now the rails are aligned, and now I will do the fumbling job of inserting the rail joiners into the other end. After a couple of seconds of fumbling, then this is the result. I can show you a finished sample of such a joint. This is the old version of the rail joiners without those little flanges at the side. Next step is to finally install the turnout. Just for fun, I'm placing all three of them. Later on I will cut that piece of track over there. Now I'm quickly connecting the turnout to the piece of track and aligning it with the ruler. To check the alignment, it is useful to just look low on the rail. Now I'm marking the spots where to drill the holes for the feeder wires. A special marking technique is needed for the switches, so I use a needle to mark the extreme points of left and right. For better vision, I mark the needle holes with a white pencil. Now preparing to drill. The next steps will basically be the same as shown before, so I will fast forward the video at this point. This is going to be the frog feeder, and these 2 points are the feeders for the entire turnout, because there is a contact bridge between these inner rails and the outer rails. So only these 2 feeders are necessary to have the entire turnout wired. The frog polarity is then controlled by the switch machine. For the area around the pin of the switch machine there is a special cover, and I need to elaborate it a little bit so I can fix it, because it's otherwise sticking out from underneath, and the switch is not level anymore. So that's the reason why it needs a little bit of elaboration, and then I will fix it with just a piece of tape, and then cut out again the hole, also cutting out the whole tape where necessary. Now we are ready for installation, inserting the feeder wires and aligning the turnout, connecting the rails with the rail joiners, the ties need to be arranged. Now I'm fine adjusting the position of the turnout with a ruler again, and yeah, in that area there is a kind of a dent, a slight dent in the turnout that needs to be fixed. The feeder wires fit perfectly into the hose, and later on, when ballasted, are completely invisible. This little mirror is very useful to check the alignment of the rail. And once checked, we are now ready to fix the turnout to the plywood. And now I'm adding some weights to keep down the whole turnout. I'm using super glue to fix all kind of track, not only on plywood but also on rubber mat where necessary, and through the capillary force the glue is going inside and between the 2 elements. The adhesive force is pretty high, but if you need to correct the position, it's pretty easy to remove the whole thing again. Later on, when ballasted, it's anyway held in position by the glue of the ballast. So here we are. Last check with the little mirror, and looks good. Next step is to install a switch machine. So far I have installed 3 of them. This is the one from Conrad Electronics. It has an electric motor but is switching very fast. And there is this one from Hoffman. It's slower in motion, we'll see that in a couple of seconds. And the third one is one from MTB, and is my current and future choice. Now we are going to see the speed of the different switch machines. So that's the very fast Conrad switch machine. This is the Hoffman. There are different speeds on this one. It's not very reliable in speed, so one is a little bit faster than the other one. And then we have the MTB that has a very nice slow motion. So this is the choice. To position the pin of the switch machine at the correct height, I'm using a scrap piece of the plywood and a piece of track. To temporarily hold the machine in place, I put a piece of double-sided tape on it. And then for comfort reasons, I'm doing the entire wiring before the installation, and so this way I can also check and test the machine before it is in place. Now a short test. The control switch is placed in a temporary board. I'm using a smartphone or a mirror to see where I am with the switch machine, and then fixing it with 2 screws, then adjusting, of course, and yeah, this is the result. Now I need to do the final wiring by connecting the feeders to the DCC main line, and this is the method I use to connect it. I'm always soldering everything that is electrically connected, so the method is always the same and has proven to be very reliable in the past years. The blue wires are the frog polarization, and yeah, you always have 50% chance that they are the right way around. So when I'm just going to fix them, it's just temporary, because I have to check first on top on the turnout whether they are right or not. Now everything is connected, and I'm testing right now whether there is a DC current all around, and yeah, I'm lucky. The frog has the right polarity, and now switching, and the polarity is on the other side, so we are fine so far. Now ready for a test drive with a locomotive. That's all for this episode. If you have any questions, don't hesitate to leave a comment. Also let me know if the content was useful to you. And finally, consider subscribing to my channel. I hope you enjoyed the video. Thanks for watching, and goodbye.